Good day. In this video, we're going to continue our exploration of division of fractions in word problems. And we hope to see that not all word problems are exactly the same, but it will depend on how you use your thinking and how you apply your division of fractions and other operations to make sense of the problem in order to solve it. So let's begin by reading our problem. At a concert, 2/9 of the number of adults is equal to 7/10 of the number of children. A total of 249 people attended the concert. How many adults were there? So we know that 2/9 of the number of adults is equal to 7/10 the number of children. And this is where sketching a model can clearly help us think about the problem. So let's try that. So we're going to make a sketch of the bars for adults and then for children. And hopefully this will help us make sense of the problem. So it's best to actually look at which parts do we have that are of equal in number. And that is 2/9 and 7/10. Meaning if we draw our sketch two parts for the adults, like this one, that should be of the same size as the children. The only difference is this one is cut in two parts and this one is 7 parts. 1, 2, 3, 4, 5, 6, 7. So that will help us complete our fraction. And that means I can add 1, 2, 3, and that is 7/10 already. And I can label that over here, 7/10. Next, we want to complete 2/9, so we can draw 1, 2, 3, 4. Now the sizes aren't equal, but we're just trying to make sense of the problem for now. So this is our 7/10, and this is our 2/9. So if you notice, since we only have the total, which is 249 people, that means our whole group of people in the concert is 249. It's really hard to divide it or find a common value because the sizes of our fractions are not the same. So it will make sense to try and split up the sketch of our model into equal parts. And it's hard to make bigger portions, but it's easier if we cut it into smaller parts, just like when you divide fractions. So let's show 2/9 and 7/10. This is 2/9 and this is 7/10. We know that they are supposedly equal, so they are the same size. So that means we can actually divide 2/9 into 7 parts to somehow make sense of how big each part is. And 2/9 divided by 7 is the same as getting the reciprocal and multiplying. And that is 2/63. So we can actually cut these two into 60/3. So if we try to draw dotted lines to mark each one over here to show the 7 parts, each part is actually 2 out of 63. So this means we've found a common way of cutting or dividing the group of children as a fraction and the group of adults as a fraction to have the same size in terms of parts. So what does that tell us? First, it tells us that our adults is actually 63 out of 63 if taken as a fraction. And our children, if represented using the same sized portions as the adults, is 20 over 63. Because there are 10 parts and each part is 2 over 63. Now we were able to represent the fraction of adults and the fraction of children into parts of the same size. So how many parts do we have altogether to represent the total number of concert people? There are 63 parts for adults and 20 parts for children. So if we're talking about everyone who attended the concert, we have a total of 83 parts. And we know for fractions that if you want to represent the adults into the total number of concert attendees, you have 63 adults. And now we can use multiplication of fractions this time because we want to solve for 63 over 83 of 249. And we can solve for that by multiplying the fractions. So we can now multiply 63 over 83 times 249. And if you notice, 249 and 83 can be cancelled. And you'll be left with 1 and 3. And if you do that, you will end up having a total of 189 adults. And that's how we actually apply division by using equal portions to make sense of more complex problems like this example that we have here. I hope that you learned a lot from this video. I'll see you next time. Goodbye.